Let's say we have a charge, we have a positive charge, and here we have a negative charge. Here we have a negative charge. Let's say here is our Q1, our Q2. Okay, first of all, what do we mean by Q1? Q1 is our charge. It's charge and is measured in coulombs. And the second charge, Q2, our second charge, and it is also measured in coulombs. And the mathematical equation for Coulomb's law is the electric force is equals to the K times the charge 1 and charge 2 divided by the distance r squared. Okay, this is the exactly explanation of the Coulomb. Okay, let's say here is our distance r, our distance, and we know that like charges repel and unlike charges attract. Okay, here we are having what? We are having our unlike charges. Okay, let's say here we have our charge 1 and charge 2. Okay, the distance, this distance is just showing us the distance between the Q1 and Q2. This is the useful of this distance. It's just showing us distance far away from the charge 1 and charge 2. And let's say our force, the electric force, it is measured in Newton. We know that force is measured in Newton, and K is equals to 1/4 times E naught. And what is the value of K? Or what is the value of 4? Okay, let's say the value of E naught. E naught is equivalent to 8.85 times 10 exponentially of negative 12 Newton meter square times Coulomb square. When you divide 1/4 times pi, which is 22/7, or 3.14 times E permittivity, the value of E naught or E permittivity is 8.85 times 10 to the exponential of negative 12, and our value of K constant is equal to 9.0 times 10 exponential of 9, or also Newton meter square times Coulomb square. When you also divide 1, let's say when we are going to prove that this formula, okay, let's say the value of K is equal to 9.0, we can just say 1/4 times, let's say 3.142 times 8.85 times 10 exponential of negative 12, and it will exactly give you this value, which is what? 9.0 times 10 exponential of 9 Newton per meter square times Coulomb square. Okay, let's say that our distance is given in centimeter, and when we are giving distance in millimeter. Okay, to convert, you know that when distance is given in centimeter or millimeter, we have to convert it into meter. Okay, to convert centimeter to meter, we are going to times, okay, let's say we are going to times it by 10 times 10 exponential of negative 2, or divided by 100. If we are given millimeter, we are going to times it by 10 exponential of negative 3, which is divided by 1000. Okay, we know that the charge of electron, charge of proton, let's say charge of proton is equal to 1.6 times 10 exponential of negative 19, and one charge of electron is equal to 1.6 times 10 exponential of negative 19, but we know that electron has a negative sign, so we have to insert our negative sign, which is 1.6 times 10 exponential of negative 19. Okay, let's say we have, if we are given a question is just coming like, let's say our charge has already given us 10 microcoulombs, or let's say we have another charge, for instance, let's say we have 10 nanocoulombs or 10 millicoulombs, and 10 picocoulombs. So The value of micro, nano, milli, and pico are as follows. Let's say that one microcoulombs. This sign, whenever you see the sign mu, it's microcoulombs. Microcoulombs is 1 times 10 exponential of negative 6. When you are given a value, let's say 10 microcoulombs, so you have to times 10 times 10 exponential of negative 6 so that you can eliminate the mu, which is what? Microcoulombs. Okay, let's say we are given milli. 1 milli is equals to 1 times 10 exponential of negative 3. And nano is, you know that nano is 1 times 10 exponential of negative 9. And pico, 1 pico is equals to 1 times 10 exponential of negative 12. Okay, these are some values that you may need to know in order to solve some problems under Coulomb's law. Okay, I think it's just for that an introduction to Coulomb's law.